Hey guys, Mr. Longbreak here. I hope all is well. I miss you guys a lot. We're going to go ahead and get started with the first topic of the motion unit, which is distance versus displacement and motion diagrams. Now, I posted the answer key to the notes on Schoology, and you'll notice that this is a lot shorter. I basically stripped it down to the most essential information. So if you understand the stuff that I'm going through in this video, you should be good to go. So let's start with distance versus displacement. Distance is the total ground covered by an object, and I'll be calculating everything's distance in these two graphics with green, versus displacement, which we've actually talked about displacement when we were doing density, the first unit of the year, but displacement is an object's overall change in position. And basically we find that by going start point directly to the end point. So sometimes distance and displacement can be the same, but usually displacement is going to be shorter than the distance. And we'll use these two graphics to calculate a distance and a displacement. So first, let's look at the top graphic, and here's where this object or person is starting, and they walk 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the distance here, and we'll just use meters as the unit. It doesn't give us a unit, but 21 meters. Now, displacement is going to be a little bit different. It's going to be the total distance from the start point to the end point. So we're going to go directly from the start to the end, and we'll see how displacement could be different. So the displacement would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 meters in that particular picture. So displacement is the direct path from the end to the start, and the distance is the overall path that that object covered. Now we'll go ahead and do the second example. So if we look down here, we have a car, and maybe we say this is home, maybe we say that this is school, and maybe we say that halfway between the home and the school is a store. So this car, if we calculate its distance, it started at home and went to school, and that was 1,000 meters. And then it went back towards home and stopped at the store, which was 500 meters. So if we were to calculate the distance, it would be the total ground covered. That would be the 1,000 meters that it drove to school and the 500 meters that it drove to the store, giving us a total of 1,500 meters. Now we'll do the displacement. The displacement, remember, is an object's change in position from start point directly to end point. So if we look, this is the car's starting point. This is where the car ended, and the displacement will be the distance from that starting point to the end point, which would just be 500 meters. And so we're going to go ahead and label down here displacement 500 meters. So hopefully those two graphics there help show the difference between distance and displacement. Now we're going to go ahead and go to the second topic for today, and that is motion diagrams. And the key here is to know how to draw a motion diagram and how to interpret or understand what's happening in a motion diagram. This will be the first of 4 ways that we draw or represent motion, and it's usually the easiest one. So the first thing that we need to do is make sure we understand how to represent each of these things with a motion diagram. And so constant speed. First of all, constant speed is when something is moving the same speed for a duration of time. So think about a treadmill. When you're running on a treadmill and you put that speed to 10, you're running at the same speed for a certain duration of time. All right, versus say you're running to first base in baseball. You start off a little bit slower, then you speed up, and then once you get to first base, you slow down. That's a change in speed. That would not be constant. So constant speed, think about a treadmill, or think about cruise control in your car. When you set your car to a certain speed, say 65 miles per hour, and you stay at that speed. Well, the way we're going to represent that is by the dots being evenly spaced. Evenly spaced. So if I have a motion diagram and I have dots that are evenly spaced apart, that means that the object is moving at a constant speed. Next is going to be increasing speed. So if something is getting faster and faster and faster, we are going to move the dots further apart. And so if my dots started this far apart, I'd then move them further apart and then even further apart. That would mean that that object is speeding up. And that kind of makes sense. Think about like stride lengths. If you're going faster, your strides or your steps get further and further apart. So increasing speed, you're going to make the dots further apart. Decreasing speed, meaning you're slowing down, those dots are going to come closer together. And so if they started off like that, they would come closer and closer together. And that would mean that the object is slowing down or decreasing its speed. Next is direction, and actually motion diagrams do not show direction. So that's a big downfall of a motion diagram. They don't show whether it's going north, east, south, or west. They don't show a direction. So we're not going to put anything there. And then if an object stops or a person stops, the way we show that is a larger dot. And so what I mean by that is, say we had an object moving, and that would be constant speed. If we want to show that it stopped, we're going to draw a larger dot. And that's going to represent that that object came to a stop. Okay, so now let's go ahead and try to draw some motion diagrams, or sometimes they're called motion maps. So this first example says a runner starting at rest and then speeds up or increases their speed. So first, let's make sure we represent the runner starting at rest, and we're going to do that by drawing a larger dot. And then he starts or she starts speeding up. And so I'm going to start by putting the dots close together and then gradually moving them further and further apart. That would show that that runner is speeding up, making these dots space further apart. So that's the first example. Let's go ahead and move to the second example. It says a runner already in constant motion slows down. So here we don't have an object starting at rest. We have a runner that's in constant motion. So I'm going to draw constant motion by making sure that the dots are evenly spaced. So I have my dots evenly spaced, showing that the object is running at a constant speed. Then I'm going to show the object slowing down. And the way I do that is by putting the dots closer together. So I will go ahead and do that. And that shows that that particular object slowed down. So the object was at constant speed. That's why I had these initial dots evenly spaced, and then the object slowed down, making sure that I move the dots closer together. So that's how to draw a motion diagram or a motion map. Now let's work on how to interpret what's going on in a motion diagram. And so we have this first example, and let's look at this first part of the motion diagram. You always want to split up what's happening unless the same thing is happening throughout the entire diagram. So if we look at this first diagram, we see that the dots are coming closer together. So we should say that this object is slowing down, because the spacing of those dots is coming closer together. Now, after the object slows down, we have a set of 4 dots that are evenly spaced. And so since those dots are evenly spaced, we would say now this object is moving at a constant speed. And I'm going to say a constant walk for its speed. And that's because those dots are pretty close together. And if they're close together, that means it's not moving very quickly. We could have a constant speed where the dots are further apart. That would be more like a jog or a sprint. But here they're very close together. So I'm going to say a constant speed, and they're pretty close. So I'm going to say a walk. So that's the first one where we're interpreting the motion. Now let's do this last one. It says describe the motion below. And we have this first set of 3 dots, and they are evenly spaced. But if we compare those two, they are both constant speed because they're both evenly spaced, except the ones below in green are further apart. So I'm going to say constant speed again, but maybe this would be a jog, because those are further apart than the one we did right above. So we have a constant speed, or it's jog, or a medium speed. And now we have this second set from here to here where they are getting further apart. And so now this object is speeding up, or increasing its speed because those dots are moving further apart. So that's it for today. I hope this helps you understand how to draw and interpret motion diagrams, but also how to know the difference between distance and displacement. I hope you guys are doing great. If you have any questions, you can always reach out to me via email or Schoology. I miss you guys. Stay safe, and we'll talk to you soon.